Hello everyone and welcome to the next in the video lecture series for rational expressions. Today we are going to be taking what we learned in the last video, which was how to write rational expressions in terms of the lowest common denominator, and we're going to take that a step further to actually add and subtract rational expressions. So just as a recap of how to add and subtract fractions, you remember, in order to add or subtract any sort of fraction, you need a common denominator. With regular fractions and with rational expressions, you cannot just simply add and subtract the numerators and add and subtract the denominators. You need to have a common denominator in order to add or subtract any sort of fraction. So we took these same three pairs of fractions in the last video and we expressed them in terms of their common denominators. So 3/4 and 1/6 were 9/12 and 2/12. So what we're going to do now is we are going to actually subtract them. So once you found the common denominator, 12, you're going to carry that over into your final answer, and the only thing that you add or subtract are the numerators. 9 minus 2 gives us 7. Then if there is any reducing to do, you then reduce the fraction. 7/12 cannot reduce, so 7/12 would be our final answer. Now for 1/2 and 1/3, these were denominators that had no common factors, and we already expressed them in terms of their common denominator, 3/6 and 2/6. So now what we're going to do is add them together. So I'm going to take that common denominator 6, I'm going to carry it over into my final answer, and I'm just going to add the numerators. 3 plus 2 gives us 5. And since 5/6 does not reduce, this is our final answer. Then for 1/2 and 3/10, this was an instance where one denominator was a multiple of the other, so we expressed them in terms of the common denominator, so that gave us 2/10 and 3/10. And remember, order matters with subtraction, so we're going to subtract left to right. I'm going to carry over that common denominator 10 into my final answer, and subtract the numerators. 2 minus 3 is -1. Now remember, negatives with fractions can go in a variety of places. You can put the negative here in the numerator, or you could put the negative off to the side. What I would avoid is putting the negative in the denominator, so either put it in the numerator or put it off to the side in the middle like this. Now, when you are adding or subtracting rational expressions, you have to have a common denominator. So that whole process in the last video of finding the lowest common denominator, you need to do that first. So you're going to factor anything in the denominators that looks even vaguely factorable, and you're going to take advantage of common factors. So you're going to then make the denominators match using multiplication. The only thing that you are going to add or subtract are the numerators. The denominator, that common denominator that you find, you're going to carry over into your final answer. Now, when you are subtracting, this part is actually extremely important. The entire second numerator is being subtracted. So if the second numerator contains more than one term, all of those terms are being subtracted. So when you are subtracting, you need to distribute the negative to every single term in the second numerator. So with addition, you don't have to worry about this too much, but with subtraction, you do have to worry about distributing that minus sign to every single term in the second numerator. So here are the steps to adding and subtracting rational expressions. The first thing that you're going to do is you're going to factor anything that looks remotely factorable. Now remember, you cannot do any cross-reducing. Cross-reducing only works with multiplication. Do not cross-reduce with addition or subtraction. Remember, you cannot cancel out common terms across addition or subtraction. Then, once you have everything factored, you're going to find common denominators. Remember that whatever you do to the bottom of a fraction, you must do the exact same thing to the top. Now, resist the urge to cancel anything out. The whole point of finding common denominators is so that you can carry over that common denominator into your answer. And the only thing that you add or subtract are the numerators. Now, if you have subtraction, you need to remember to distribute the negative to every single term in the second numerator. Now, you cannot cancel anything out at this point because there's going to be a lot of addition and subtraction, and remember that you cannot cancel out common terms, only common factors. You can only cancel things out across multiplication. So the only way that you could simplify further is to distribute the numerator and refactor it if possible. This may or may not allow you to cancel out common factors with the denominator. Now, do yourself a favor, leave the denominator alone. The denominator will already be factored, so if you have any hopes of getting any common factors to cancel, you're going to want to leave the denominator factored. So just don't distribute the denominator. Leave the denominator alone, just don't touch it, carry it over into your final answer, and leave it alone. What you should focus on is simplifying, distributing, combining like terms, trying to refactor the numerator, and see if there are any factors in the numerator that can cancel out with the denominator. This is not always going to happen. There are going to be plenty of instances where the numerator doesn't really simplify that far and there are no common factors to cancel out. So don't expect a whole lot of these to do a whole ton of simplifying. So what we're going to do for this first one is we are going to perform this indicated operation, which is subtraction. Now, because that is subtraction, I am going to put parentheses around the second numerator because you have to remember that with subtraction, every single term in the second numerator is getting subtracted. So we are going to have to eventually distribute that minus sign to every term in the second numerator. Now, before we get to that, let's look at the denominators, x squared minus 1 and x squared minus 1. These already are a common denominator. So what we're going to do is, since they already have a common denominator, a lot of the work has already been done. So I'm going to take that common denominator and I'm going to carry it over into my final answer so far. And I'm just going to subtract the numerator. So I'm going to take the first numerator, 3x squared, kind of left alone. Then I am going to subtract the second numerator with parentheses around it, x plus 4. So then we're going to take that subtraction and we are going to distribute it to every single term in the second numerator. So I'm going to leave the denominator alone for right now, leave the 3x squared alone, and I'm going to distribute that negative. So negative times x is minus x, negative 1 times 4 is minus 4. Then what we're going to do is we're going to see what factors, and we're going to try and simplify this. So the denominator is a difference of squares, so that is going to factor as x plus 1 times x minus 1. Now the numerator actually is factorable. This is going to involve the AC method that we learned in section 5.3 in the last chapter. It involves multiplying the first number by the last number and factoring by grouping. So if you have any questions on that, please email me and let me know. But when you factor the numerator, it actually factors as x plus 1 times 3x minus 1. Now that you have factored, remember there's multiplication there and multiplication there. You can cancel out common factors across multiplication. So now that we have multiplication, any common factors that we see can cancel out, and I see a common factor of x plus 1 that can cancel out. Now for the last two factors, remember these two parentheses are not exactly the same, so resist the urge to cancel out the minus 1s. Those are common terms, not common factors, and they don't count. So this is now going to be our fully simplified final answer. So then for this next one, if you take a look at this, I'm going to put these two denominators in parentheses, and while I'm at it, I'm going to put the x minus 3 in parentheses as well. These two denominators have a common term, but that doesn't count. These two denominators have no common factors, and they are obviously not the same. So because these two denominators are not the same, I need to first find a common denominator. And because they have no common factors other than 1, the lowest common denominator is simply going to be their product. So what I'm going to do is I'm going to take this x plus 4 and I am going to multiply it by x minus 2. Then whatever you do to the bottom of a fraction, you need to do the exact same thing to the top. So I'm going to multiply the top by x minus 2. Then I'm going to do the same thing to the other fraction. So I'm going to take this x minus 2 and I'm going to multiply it by x plus 4. Then whatever you do to the bottom, you need to do the same thing to the top. Now before I worry about this addition here in the middle, I am going to simplify the numerators by distributing, and I'm going to just kind of leave the denominators alone. So I have x minus 2 times x plus 4. And I'm going to fully distribute the numerator. So x times x is x squared. X times minus 3 is minus 3x. Minus another 2x is a minus 5x. And then negative 2 times negative 3 is plus 6. Then I've got that plus sign here in the middle. And then for the other fraction, I'm going to, again, leave the denominator alone. And I'm going to do the same thing in the second fraction's numerator. I'm going to distribute this x. So x times x gives us x squared. and x times 4 gives us plus 4x. Now that I have a common denominator, now I am actually ready to add these two fractions together. So I'm going to carry over that common denominator into my final answers so far. So we have x minus 2 times x plus 4. And I'm just going to add the numerator. So I'm going to take the first numerator, which was that x squared, minus 5x, that is a squared, minus 5x plus 6. And then I'm going to add to it the second numerator, x squared plus 4x. Now, since this is addition, we don't have to worry about distributing anything. You don't have to worry about distributing any minus signs. It's addition. So all we have to do at this point is let's combine some like terms. So again, I'm going to continue to leave the denominator alone, x minus 2 times x plus 4. And let's combine some like terms in the numerator. So I've got this x squared plus x squared is going to give us 2x squared. And then minus 5x plus 4x is going to give us minus 1x. And then we've got this plus 6. Now, unfortunately, this numerator is not factorable, because even if you use the AC method, there are no two numbers that multiply to positive 12 and add up to negative 1. So since this numerator is not factorable, nothing can cancel out with the denominator. This cannot simplify any further, so that is our final answer. So for this next one, I see that there is some factoring to do, so I'm going to factor anything that I could possibly factor first, and then I'm going to work on finding common denominators. So in the first denominator, this is a difference of squares, so it is going to factor as x minus 2 times x plus 2. I'm going to leave that plus sign in the middle alone for right now. I'm going to put parentheses around this x minus 3. And then I'm going to factor the second fraction's denominator. If you notice that these two terms have a common factor of x, so I'm going to factor an x out of both terms. Gives us x minus 2. So you'll also notice that these two denominators have a common factor of x minus 2. Take advantage of that. However, the first denominator has an x plus 2 and the second denominator does not. So I'm going to multiply the second denominator by x plus 2. Then whatever you do to the bottom of a fraction, you need to do the exact same thing to the top. Now remember, when you take out a common factor, you write it with multiplication. So this standalone x right here is technically considered a factor. So the second denominator has an x in it, whereas the first denominator does not. So I'm going to multiply that first denominator by x. Whatever you do to the bottom, you need to do to the top. So then I'm going to work on simplifying as much as I can. So the first fraction is going to be 6x, and I'm just going to leave the denominator alone as x times x minus 2 times x plus 2. Then I got that plus sign in the middle. I'm going to do the same thing to the other fraction. I'm going to leave the denominator alone as x times x minus 2 times x plus 2. Then I'm going to fully distribute the second numerator, so x times x will give us x squared. X times 2 is 2x, minus 3x is minus 1x. And then negative 3 times 2 is minus 6. So then I'm going to work on adding the numerator, so I'm going to take that common denominator and carry it over into my final answers so far, so x times x minus 2 times x plus 2. Then I'm going to simply add the two numerators together. So I have 6x, that first numerator. Then I am going to add to it the second numerator, x squared minus x minus 6. And since this is addition, we don't have to worry about distributing any negatives. So at this point, all that we are going to do is combine some like terms in the numerator, continuing to leave the denominator alone. So I'm going to leave the denominator as x times x minus 2 times x plus 2. And I'm also going to put this in standard form while I'm at it. So I'm going to put the x squared first, and I'm going to combine some like terms. So 6x minus 1x is plus 5x. And then I have that minus 6. However, At this point, yes, the numerator does factor. The numerator factors as x plus 6 times x minus 1. However, even though the numerator factors, there are no common factors with the denominator. So even if you did factor the numerator, nothing is going to cancel out with the denominator. The top and bottom have no common factors. So because of that, we're going to call it good here. That is going to be our final answer. Nothing can cancel out, so this cannot reduce any further. So then for this next one, these two denominators are obviously not the same. So because of that, we're going to have to find common denominators. Now, there's no factoring to do in either of these denominators, and they have no common factors. So because they have no common factors, the lowest common denominator is simply going to be their product. So I'm just going to take the first numerator and the first denominator, and I'm going to multiply that first denominator by x plus 1. Whatever you do to the bottom, you have to do the same thing to the top. Then I'm going to multiply that second denominator by 2x minus 3. And then whatever you do to the bottom, you need to do to the top. So then I'm going to leave the denominators alone. So I'm going to leave the denominators as x plus 1 times 2x minus 3. And I'm going to simplify the numerators by distributing. So I'm going to distribute the 2x. So 2x times x is going to give us 2x squared. And then 2x times 1 is going to be plus 2x. Then I'm going to leave that minus sign in the middle alone for right now. And I'm going to do the same thing for the other fraction. We have x plus 1 times 2x minus 3. Then 1 times 2x minus 3 is going to be 2x minus 3. Now resist the urge to cancel anything out, because the whole point of finding common denominators is so that we can subtract those numerators. So, sorry about that. The common denominator we're going to carry over into our final answer so far. So we have x minus 1 times 2x minus 3. And I'm going to subtract the numerators. Now because we are subtracting, I am going to put parentheses around this second numerator. So the first numerator we're just going to kind of leave alone as is. So we've got 2x squared plus 2x. Then I am going to subtract the second numerator with parentheses around it, 2x minus 3. So with subtraction, you do have to remember that you have to distribute the negative to every single term in the second numerator. So this minus sign is going to get distributed to everything in the parentheses that is next to it. So again, leave the denominator alone. Leave that first numerator alone, 2x squared plus 2x. And I'm going to distribute this minus sign to everything in the second numerator. So I have minus 2x. Minus minus is a plus 3. So then we're going to continue to leave the denominator alone. And I'm going to combine like terms in the numerator. So 2x minus 2x can cancel out, giving us 2x squared plus 3. Now 2x squared plus 3 is not factorable. So this is going to be our final answer. Remember, do not cross off the 3's, do not cancel out any of the 2x's. Those are common terms, not common factors. So because the numerator does not factor, that is going to be our final answer. You're going to see problems like this on your homework. So whenever you take a rational expression and you add to it just a whole number such as 1, remember you can always turn any whole number into a fraction by putting it over 1. So if you see something like this where you have a regular whole number plus a rational expression or minus a rational expression, just turn the whole number into a fraction by putting it over 1. Then these two denominators are obviously not the same, so we're going to find common denominators. Now, the common denominator between 1 and x squared is going to be x squared. So I'm going to take this first denominator, I'm going to multiply it by x squared. Whatever you do to the bottom, you need to do to the top. Now, because multiplying by 1 doesn't really do anything, we don't really need to do anything to that second fraction. We will already have common denominators. So rewriting this in terms of common denominators, x squared times 1 is going to be x squared over x squared plus 3 over x squared. Then, now that we have a common denominator, I'm going to carry it over into my final answers so far. And I'm going to just add the numerators. So I have x squared plus 3. Now x squared plus 3 doesn't factor. This is, first of all, a sum of two numbers that are, 3 is not even a perfect square. So since the numerator is not factorable, that is actually our final answer. Remember, do not cancel out the x squareds. Those are common terms. Common terms do not count. So then for this next one, I see that the second denominator looks like we can factor it. So I do see a common factor of 3 and a common factor of x. So let's focus on factoring it first. Now, this 7 over 9x squared, remember, there is hidden multiplication between the 9 and the x squared. So 9 is considered a factor and x squared is considered a factor. Then I'm going to, Then I'm going to factor the second denominator by taking out that common factor of 3x. And I'm going to divide each term by 3 and take an x out of each term, gives us x plus 3 divided by 3 is 1. Then from here, remember, when you take out a common factor, you technically write it as multiplication. So this 3 is a factor and this x is a factor. So we're going to make the denominators match using multiplication. So the second denominator has an x plus 1 and the first denominator does not. So I'm going to multiply that first denominator by x plus 1. Whatever you do to the bottom, you need to do the same thing to the top. Now the denominators do not completely match yet. You might notice that there is a 9 here and a 3 here. And because they're being multiplied, they're technically considered factors. So what can you multiply 3 by to turn it into 9? Well, you can multiply it by 3. So I'm going to multiply this by 3. And this denominator has a standalone x squared, and this denominator just has an x. So what do you multiply x by to turn it into x squared? Well, you're going to multiply that by x. So I'm going to multiply the second denominator by 3x, and then whatever you do to the bottom, I'm going to do the exact same thing to the top. So then for the denominators, I'm going to just leave the denominators as 9x squared times x plus 1. And the only thing I'm going to distribute are the numerators. So I'm going to distribute this 7 to the x plus 1, giving us 7x plus 7. Then I got that plus sign in the middle, and I'm going to do the same thing here. So 3 times 3 gives us 9. X times x gives us x squared. And then I have x plus 1. And then x times 3x is going to be 3x squared. Then I'm going to simply add the two numerators together, carrying that common denominator over into my answers so far. So I have 9x squared times x plus 1. And I'm just going to add the two numerators. Now, because it's addition, we don't have to worry about distributing any negatives. So I'm just going to take the first numerator, 7x plus 7. Then I'm going to add to it the second numerator, 3x squared. Then let's at least put the numerator in standard form so that we can even begin to think, can this factor? So we have 9x squared times x plus 1 in the denominator. And then the numerator is going to be 3x squared plus 7x plus 7. So this would involve the AC method, but however, even if you do the AC method, this is not factorable. There are no two numbers that multiply to 21 and add up to 7. So because the numerator is not factorable, this is going to be our final answer. So for this next one, we're going to start that in pretty much the same way. I'm going to put parentheses around that x plus 1. I see a lot of things that look like they can factor, so I'm going to go ahead and factor both denominators, and then I'm going to start finding common denominators. So the first denominator is a perfect square trinomial, and you can go ahead and write it separately as x plus 2 times x plus 2. You do not have to worry about writing it as x plus 2 squared, although you can a little bit later on. But for now, I would leave it like this because we're focusing on common denominators for right now. Then for the second denominator, that is a difference of squares, so that is going to factor as x minus 2 times x plus 2. All right, so there is a common factor here of x plus 2. There's an x plus 2 there and an x plus 2 there. So we're going to take advantage of that. Now the second denominator has an x minus 2 and the first denominator does not. So I'm going to multiply that first denominator by x minus 2, and then whatever we do to the bottom, we're going to do the same thing to the top. Then the first denominator has an extra x plus 2, whereas the second denominator only has 1. So I'm going to multiply that second denominator by x plus 2. Whatever we do to the bottom, we're going to do the same thing to the top. Then I'm going to leave my denominators alone, and at this point, if you want to condense the x plus 2 into x plus 2 squared, you can, although it's not necessary. But the big thing is, don't distribute the denominators. You're only going to make things worse. What I am going to distribute are the numerators. So x times x will give us x squared. X times minus 2 is minus 2x, plus 1x is minus 1x, and then 1 times negative 2 is negative 2. Then I've got that central minus sign, and I'm going to, for the second fraction, again, leave the denominator alone. So x plus 2, x plus 2, x minus 2. And I'm going to distribute that 6. So 6 times x is 6x, and then 6 times 2 is plus 12. Now, because this is subtraction, I'm going to put the second numerator in parentheses because we are going to have to remember to distribute. So I'm going to carry over that common denominator, and I'm going to, since I'm running out of room, I'm going to go ahead and condense the x plus 2 into x plus 2 squared times x minus 2. And I'm going to subtract the two numerators. So I'm going to take the first numerator, left alone, x squared minus x minus 2. Then I'm going to subtract the second numerator with parentheses around it, 6x plus 12. So because this is subtraction, you do need to worry about distributing that negative to every term in the second numerator. So I have x plus 2 squared times x minus 2. So I'm going to, again, leave the first numerator alone, x squared minus x minus 2. And I'm going to distribute that negative, so minus 6x, and then minus 12. So then I see some like terms in the numerator that I could put together. So I'm going to combine some like terms in that numerator. And while I'm at it, I'm going to make sure that my final answer is in standard form. So I'm going to have the x squared first. Negative x minus 6x is minus 7x, and then minus 2 minus 12 is minus 14. Now the numerator is actually not factorable. There are no numbers that multiply to negative 14 and add up to negative 7, so because the numerator is not factorable, this is going to be our final answer. So then for this next one, it's going to be a very similar idea. We're going to start by factoring everything that we can possibly factor. So it looks like both denominators can factor, so I'm going to start with that. So factoring the first denominator, I'm looking for two numbers that multiply to 2 and add up to 3, which are x plus 2 times x plus 1. And then for the second fraction, I went ahead and put the 2x minus 3 in the numerator in parentheses. And x squared minus 1 is a difference of squares that is going to factor as x minus 1 times x plus 1. So there is a common factor of x plus 1 that we're going to take advantage of. However, the second denominator has an x minus 1 and the first denominator does not. So I'm going to multiply that first denominator by x minus 1. Whatever we do to the bottom, we need to do the same thing to the top. Then the first denominator has an x plus 2 and the second denominator does not. So I'm going to multiply that second denominator by x plus 2. Whatever we do to the bottom, we need to do the same thing to the top. So let's distribute the numerators, and at this point I'm going to leave the denominators alone. So I'm going to leave each denominator as x minus 1 times x plus 1 times x plus 2. And I'm going to do the same thing for the other denominator while I'm at it. And then x plus 2. So leaving the denominators alone, we're going to distribute the numerators. So I'm going to distribute this x, so x times x is x squared minus 1x. Then I'm going to fully distribute the other numerator, so 2x times x is 2x squared. I'm going to combine like terms as I go, so 2x times 2 is 4x, minus 3x will be plus 1x, and then negative 3 times 2 is minus 6. Now that we have a common denominator, now we can add the two together, and because this is addition, we don't have to worry about distributing anything. So I'm going to carry over that common denominator, x minus 1 times x plus 1 times x plus 2. And I'm going to add the two numerators. So I'm going to take the first numerator, x squared minus x, and I'm going to add to it the second numerator, 2x squared plus x minus 6. So then at this point, I am going to combine some like terms and see what I can do with it. So again, leave the denominator alone. So we have x minus 1 times x plus 1 times x plus 2. And while I'm at it, I'm also going to write the numerator in standard form. So I've got this x squared plus 2x squared is going to give us 3x squared. And then minus x plus x is going to cancel out. And then I have this minus 6. Now at this point, yeah, there is a common factor in the numerator of 3, but even if you factor out the 3, the numerator is not a difference of squares, unfortunately. You'll get x minus 2. So the numerator is actually not factorable. I mean, you can factor out the 3 if you want. It really doesn't do much because there are no common factors that can cancel out with the denominator. So because of that, this is going to be as good as it's going to get. That can be our final answer. I promise that the easiest way to master this is to just do a whole bunch of practice problems and to just do a whole bunch of these. Remember, any point in this video, if you want to attempt a problem before I do it, just pause the video and then resume it when you are done working. So for these two denominators, I'm going to factor them first. So in this first denominator, I see that there's a common factor of x. So I'm going to take a common factor of x out. Remember, when you take out a common factor like this, it's written with multiplication, so it is a factor, and it is going to factor into your lowest common denominator. Then I'm going to do the same thing over here. I'm going to put the x plus 4 in the numerator in parentheses, and I'm going to factor the second denominator. So two numbers that multiply to 1 and add up to 2 are x plus 1 times x plus 1. So there is a common factor of x plus 1 here. However, the second denominator has an extra x plus 1, whereas the first one does not. So I'm going to multiply that first denominator by x plus 1. What we do to the bottom, we need to do the same thing to the top. And the first denominator has this standalone x factor, whereas the second one does not. So I'm going to multiply that second denominator by x, and then do the same thing to the top. So then for my two fractions, remember we're going to leave the denominators alone. So I'm going to leave the denominator as x times x plus 1. If you want to condense that as x plus 1 squared, go ahead, you can do that. But again, don't distribute the denominators. You're going to leave them factored. What we are going to distribute are the numerators. So I'm going to distribute that 3. 3 times x is 3x squared. Sorry, 3x. Sorry about that. And then 3 times 1 is going to be plus 3. Then I'm going to do the same thing over here. I'm going to distribute this x, so x times x will give us x squared, and then x times 4 will give us plus 4x. Now, because this is subtraction, I am going to put parentheses around that second numerator, because with subtraction, you will have to worry about distributing that minus sign to every single term in the second numerator. So I'm going to carry over that common denominator into my answer so far. And I'm going to subtract the numerator. So I'm going to take the first numerator left alone, 3x plus 3. And I am going to subtract the second numerator with parentheses around it, x squared plus 4x. Then I'm going to distribute that negative to every single term in the parentheses. So again, I'm going to leave the 3x plus 3 alone. And I'm just going to distribute that minus sign. So we get minus x squared, and then minus 4x. Then what I'm going to do is I'm going to rearrange this so that it is in standard form, and then I am going to combine some like terms. So I'm going to put that minus x squared first, minus x squared. And I'm going to combine the x's, so 3x minus 4x is minus 1x. And then I have plus 3, and I'm going to leave the denominator alone. And I just went ahead and condensed that x plus 1 times x plus 1 to x plus 1 squared, just for the sake of room. Then I'm going to try to refactor the numerator. So because the x squared term is negative, I'm going to start by factoring a negative out of each term in the numerator. It might help, it might not. So if you divide each of these by -1, this is what you get. And it looks factorable, but the numerator is actually not factorable. There are no numbers that multiply to -3 and add up to +1. So because the numerator is not factorable, this is as far as we can get, and that is going to be our final answer. So for this next one, if you look at the two denominators, they look extremely similar. The only difference between these two denominators is that this second one is a 3 minus x. Remember, order matters with subtraction, and you can't just switch the order of subtraction however you want. But what you can do is if you want to switch the order of subtraction, you can first factor out a -1. So that's what I'm going to do first. So I'm just going to leave the first fraction alone for right now. Leave that minus sign in the middle alone, and I'm going to factor a -1 out of the denominator. And when you factor a -1 out of the denominator, you can switch the order of subtraction. We saw this a couple sections ago. Now, you have to worry about common denominators to add or subtract fractions. So if you have a negative that's being multiplied in the denominator, again, this only works when the negative is being multiplied, you can take it out of the denominator, because as long as the negative is somewhere, the whole fraction counts as negative. So just get it out of the denominator so you don't have to worry about it. What I'm going to do with this negative is I'm going to move it to the middle of the fraction. So I'm going to move it to the middle to give us -5 over x minus 3. Now, yes, we do have a double negative. Remember, subtracting a negative is the same as adding. So I'm actually going to change that to addition. So I have this is 2x, sorry about that. So I have 2x over x minus 3. That minus turned into plus 5 over x minus 3. Now that we've done that, notice the denominators are the same. So we already have a common denominator now, so I'm going to carry over that common denominator, x minus 3, and I'm going to add the numerators. So first numerator, 2x, plus second numerator, 5. And that's it. There's nothing to factor. Since there's nothing to factor, there are no common factors between numerator and denominator that can cancel out, so this is going to be my final answer. So keep an eye out for that. Again, anytime you want to switch the order of subtraction, you can do so as long as you factor out a -1 first. So that's what I'm going to do for this next one. I'm going to put this x plus 3 in parentheses, and I am going to factor that first denominator. So I'm looking for two numbers that multiply to -8 and add up to -2, which are -4 and +2. Then for the second denominator, I'm going to factor out the -1, and I'm going to switch the order of subtraction, x minus 4. Then it is really not a good idea to have a negative in the denominator because it just makes it worse. So if you have a negative in the denominator that is being multiplied, you can simply move it either to the numerator or to the middle. So I'm going to have x plus 3 over x minus 4 times x plus 2 plus -3 over x minus 4. So we have a common factor of x minus 4 between the two denominators, so I'm going to take advantage of that. However, the first denominator also has an x plus 2, whereas the second one does not. So I'm going to multiply that second denominator by x plus 2. And then whatever we do to the bottom, we need to do the same thing to the top. Now notice, the denominators now match. This was an instance where one denominator was a multiple of the other, so we do not even have to touch the first fraction. We already have a common denominator. Also, this right here in the middle, adding a negative. Remember, adding a negative is the same as subtracting. So I'm going to do a little bit of simplifying first. So I have x minus 4 times x plus 2. I'm going to change that adding a negative to just regular subtraction. Then, leaving the second denominator alone as well, I am going to distribute that 3 in the second numerator. So 3 times x will give us 3x, and then 3 times 2 will give us plus 6. Now, because this is now subtraction, I'm going to put the second numerator in parentheses because we are going to have to worry about distributing a negative. So I'm going to carry over that common denominator into my final answer. So I have x minus 4 times x plus 2. Then I'm going to take the first numerator left alone, x plus 3, and I am going to subtract the second numerator, 3x plus 6, with parentheses around it. Now remember, the entire second numerator is getting subtracted, so we are going to distribute that minus sign to every single term in the second numerator. So again, I'm going to leave the denominator alone. I'm going to leave the x plus 3 alone. And I'm going to just distribute that negative. So we have minus 3x, and then minus 6. Then I'm going to combine some like terms in the numerator, continuing to leave the denominator alone. So we have x minus 4 times x plus 2. And I'm going to combine like terms. So I have x minus 3x is negative 2x. And then 3 minus 6 is negative 3. And that's it. There's nothing to factor in the numerator. So this is going to be our final answer, negative 2x minus 3 in the numerator. That is going to be simplified as much as possible. Now, whenever you have addition and subtraction in the same problem, remember, with order of operations, you do addition and subtraction in the order that they appear when you read the problem from left to right. So if you read the problem from left to right, this subtraction is going first and then this addition. But before I get to that, in order to do any adding or subtracting, you do need to find a common denominator. And we're actually going to need to find a common denominator between all three of these fractions. So the first thing I'm going to do is I notice that the first fraction's denominator looks like it can factor, so I'm going to factor it. Now, because I really don't have a lot of room to spare, this is going to involve the AC method. You multiply the first number by the last number, and you're going to factor by grouping. So when you factor by grouping, you're going to get x minus 1 times 2x plus 1. Remember, if you need help with that, just review your notes on section 5.3. That is when we covered this. Then I have minus 3 over, now 2x plus 1 is not going to factor, so just kind of leave it, but I am going to put parentheses around it. And then same thing over here, the x minus 1, there's nothing to factor, but I am going to put parentheses around it. So then I'm going to find common denominators between all three of these, and there's a lot of common factors here. You'll notice that this first denominator is just a multiple of the other two. So this second denominator here, this 2x plus 1, it has a common factor here, 2x plus 1. However, this first denominator has an x minus 1. So I'm going to give it an x minus 1 by multiplying it, and then whatever I do to the bottom, I need to do to the top. So now the first two denominators match. Now to make the third denominator match, it has a common factor of x minus 1, but it doesn't have a 2x plus 1, so I'm going to multiply it by 2x plus 1, and then whatever I do to the bottom, I need to do to the top. So then, it doesn't really matter if the factors are in different orders. All three denominators have an x minus 1 and a 2x plus 1, so that is going to be a common denominator, so we are all set. So at this point, I'm just going to focus on doing some simplifying. So I have this 3x plus 2, and I'm going to leave the denominators alone, x minus 1 times 2x plus 1. Leave the minus sign where it is. Then I'm going to distribute that 3 to give us 3x minus 3. And again, we're going to leave the denominator alone, x minus 1 times 2x plus 1. Then plus, I'm going to do the same thing to that third fraction, leave the denominator alone. And I'm going to distribute that 4. So when we distribute the 4, we get 8x plus 4. So then what I'm going to do is I'm going to carry over that common denominator, and I'm going to do the addition and subtraction in the order that they appear from left to right. So we're going to leave the first numerator alone, 3x plus 2. Now because this is subtraction, only the second numerator is being subtracted. So I'm going to put parentheses around the 3x minus 3, and then we are going to subtract that parentheses 3x minus 3. Now only that second numerator is being subtracted, so as soon as the parentheses end, the distributing ends. Then I'm going to add to it that last numerator, 8x plus 4. So then I'm actually going to distribute that minus sign to that second numerator. So again, leave the denominator alone. Leave the 3x plus 2 alone. And I'm going to distribute that minus sign. So we'll have minus 3x. And then minus minus gives us plus 3. And then we have plus 8x plus 4. Then at this point, I'm going to combine like terms in the numerator. There are a lot of like terms that I could put together, so I'm just going to go ahead and do that. So I got a lot of x's, so 3x minus 3x can cancel out, leaving us with just that 8x. And then 2 plus 3 is 5, plus 4 is plus 9. Now since there is no factoring to do in the numerator, and there are no common factors that can cancel out with the denominator, that is going to be our final answer. So that is it for adding and subtracting rational expressions. Remember, the easiest way to master this is to just do a bunch of practice problems. So make sure that you are doing the homework, and I'm also going to be posting additional practice problems for this chapter a little bit later once I finish the video lectures for it. So keep an eye out for that, and you're going to, I highly encourage you to do those practice problems in preparation for the exam on this. So thank you all very much for watching, and I will see you in the next video for complex fractions.